Today I am going to take a topic history, analytical, synthetic and other evidences in derivation of benzene. Okay, so chemists have found it that the most of the organic compounds are divided into two broad classes. First is the aliphatic and second is the aromatic. Okay, so aliphatic means what? Flat structures, and aromatic means which have the fragrant, pleasant smell. So benzene is an aromatic compound which smells as like a gasoline. Okay, let us see the history. Then benzene was isolated in 1825 by Michael Faraday, who determined CH ratio to be 1:1, and it was synthesized in 1834 by Elard Michaelis, who determined molecular formula to be C6H6, and he named it benzene, later known as a benzene. Okay, so let us see the analytical evidences in derivation of the benzene. Okay, so benzene has molecular formula C6H6. Then question was arise that how these atoms are arranged. The molecular formula of benzene has been found from analytical data, that is C6H6. Okay, so relatively the higher proportion of carbon and addition of chlorine to benzene molecule indicate that it is an unsaturated compound. Okay, so the various facts, depending upon the various facts that is from available time to scientists, and the tetravalency of the benzene, the various structures has been proposed. Some are the open chain structures, these are the open chain structures. Okay, so based upon the observation and tetravalency of carbon, these open chain structures has been proposed for the benzene. Okay, so these are the double bond which are present in the open chain structure of benzene, and various structures are there. Okay, but the drawbacks of the open chain structures are addition reaction usually given by the alkenes and alkynes, which are not given by the benzene. So this is the first drawback. Then second drawback is the benzene forms only one kind of the monosubstituted product, and open chain structure that form the more than one kind of the monosubstituted product as shown in these structures. Okay, and open chain structures compounds do not give the reaction such as the Friedel-Crafts reaction. So this is about the drawback of the open chain structure. Then let us see other evidences, that is the August Kekul has been proposed that the carbon atoms can join to one another forms the chains. Then in 1865 he offered an answer to the question of benzene. These carbon chains can sometimes be closed to form the rings. Okay, so the August Kekul, that is the scientist which proposed the structure like this. Okay, this represent as like a cyclohexatriene. Then all the carbon-carbon bonds in the benzene are equivalent. Okay, the molecule is usually stable. The chemist that often represents the benzene as an hexagon, okay, with an inscribed circle, and this inscribed circle indicates that all the valence 6 electrons are equally shared by all the 6 carbon atoms. Okay, means what? These electrons are delocalized or spread out all over the carbon atoms. Okay, then each corner of the hexagon that occupied by one carbon atom. Okay, and each carbon atom has occupied by the hydrogen that is attached by the hydrogen atom. Okay, so any other atom or groups of atoms which are substituted for this hydrogen atom can be shown to bonded to a particular corner of the hexagon. Okay, so this is about the synthetic evidence in derivation of the benzene. Okay, understood? Then let us see the other evidences in derivation of the benzene structure. So benzene undergo the substitution reaction rather than the addition reaction. Okay, so Kekul structure of benzene is one that would expect that this structure is cyclohexatriene. Why? Because this structure is cyclic in nature. Hexa means 6 carbon atoms and trines means 3 double bonds which are present in the ring. Okay, so this cyclohexatriene is very much similar to other compounds like cyclohexadiene and cyclohexene, but these compounds readily undergo the addition reaction, and which are the characteristic of the alkene structures. Okay, so for example cyclohexene. This cyclohexene is an alkene and it undergoes rapid addition reaction. But under the same condition, the benzene reacts very slowly or do not react overall. Okay, so and this exhibit what? High degree of unusual chemical stability. Okay, so in other addition reaction, an alkene reacts with an electrophile, okay, and thereby forming the carbocation intermediate. And in the second step, this carbocation then attacked by the nucleophile, and there is a product of the electrophilic addition reaction. Okay, so this is about the alkene. But if the carbocation form from the reaction of benzene by with an electrophile and where react with the similarly with the nucleophile, then there is a product that would be not a aromatic product. Okay, but the carbocation if loses the proton from the site of the electrophilic addition reaction, the aromaticity of the benzene is restored. Okay, so this aromatic, because of the aromatic compound is much more stable than the non-aromatic addition product, the overall reaction is more stable, that is the electrophilic substitution reaction rather than the electrophilic addition reaction. Okay, so in place of the addition product, that is addition reaction of benzene, readily undergo a new set of the reaction, that is involve the substitution reaction, and the most important are halogenation, nitration, sulfonation, Friedel-Crafts acylation and Friedel-Crafts alkylation. Okay, so all of you understood? Okay, thank you.